Good morning, you guys. Today's video is just going to be to kind of take a step back and re-clarify some things that I wasn't able to get to before, just to kind of make sure we're still doing okay. Today's also a good day to check in for office hours if you're struggling with things or you have questions, because I am going to step it up a little bit in our video tomorrow, just as a heads up. All right, so when you are ready, go ahead and pause the video. Try these 3 questions, and then when you're ready to see the answers, go ahead and unpause. All right, so when it is in standard form, you can technically convert it, like you can make it into vertex form or factor it if it's at all possible, but it does say in the instructions to keep it in the form it's currently in, which means I need to use the quadratic formula. So I need to use negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget, this is a, negative 8 is b, and positive 2 is c, okay? So I've got 8 up here, and this will be a 4. Negative 8 squared is 64, and then minus 4 times 2 times 2, which gives me 16. And 64 minus 16 is 48, so 8 plus or minus square root of 48 all over 4. Now you would think, there's a couple things, remember, you got to be careful of. You're going to want to simplify this right now, but remember, you can only simplify using that butterfly technique if there's a number in front of this, like in between the plus or minus and the square root. So you can't simplify the 48 as is, but we can reduce it. So 48 does divide by 4, but it leaves me with 12, so that's still kind of a big number. So maybe I'll try 48 divided by maybe 16. Oh, and that works. So I can rewrite it as 16 times 3, which means that reduces to 4 root 3. So if I rewrite it, now I can simplify the 8 and the 4. So 8 divided by 4, that gives me 2. Plus or minus, it'll be 1 root 3, but I don't need to write the 1 in the front. So this would be my final answer, is that x is equal to 2 plus or minus square root of 3. All right, if we solve it in vertex form, you're literally just solving it. There's no fancy trick. So subtract 36 to both sides. Divide both sides by negative 2. So 36 divided by 2 is 18. Square root both sides, so that'll give me plus or minus square root of 18 equals x plus 3. And I'm going to subtract the 3 over to the other side. But I need to check to see if square root of 18 reduces. And actually, I know off the top of my head that that does for sure divide by 9. So I'm going to turn this into 9 times 2. So my final answer is negative 3 plus or minus 3 root 2. Notice how each time I'm getting 2 answers. Okay, that's important. All right, last one. Hopefully, these 2 were not a problem for you. If you set this one equal to 0, you get one answer is positive 1. If you set this guy equal to 0, you get 2x equals negative 1, or x is negative 1/2, so no big deal there. But here's the weird part. Notice how this 3 in the front has an x with it. We've never seen that before, okay? Basically what that means is when it was just a 3, we could divide both sides by 3 and then it wasn't a problem and we kind of just ignored it. But when there's an x stuck with it, it's almost like that 3x is in parentheses just like the other factors. So we have a third answer of x equals 0. The main reason for that is if you were to double distribute this and like turn it into standard form, you would actually get an x to the third in the front of your equation. That's why we get 3 answers. Versus when we have an x squared, we only get 2 answers. Okay, so I just wanted to make sure we kind of talked about that because we've never seen one like that before. All right, so don't forget, finding x-intercepts, you plug in the 0 yourself. Solving a quadratic, they've already plugged in the 0 and they want to know what x is, but the procedure is exactly the same, okay? So below it says the quadratic function x squared minus x minus 6 is in standard form. To graph this, we know that we can complete the square, but it's not convenient to do so with an odd b value, right? With this negative 1 in the middle, taking half and squaring it and all that is kind of not ideal. So we need another option. Well, we can write that same equation like this, okay? This is written in factored form. Factored form is useful for finding x-intercepts so we can graph. It's also the easiest of the three forms to solve in, which I think you would agree with me there, right? You just set all your parentheses equal to 0, boom, there's my answers. So what I want you guys to do is I want you to practice factoring, okay? So factor the following quadratics. Once you have your answer, if you are uncertain it is correct, double distribute to turn the equation back into standard form to check that you factored it correctly, okay? So I want you to try questions 1 through 6, pause the video, and then when you're ready to see the answers, go ahead and unpause. All right, so remember, if you're still struggling with factoring, the best way to think of it is I need two numbers that add to give me the guy in the middle, and multiply to give me this one. So I could use 1 and 24. I could use 2 and 12. I could use 3 and 8. And then I could use 4 and 6. Those are my options. So ones that make me think of -10 is actually this one right here and this one right here. So now I have to play with kind of negatives and positives and see what works. Well, if it has to multiply to give me +24, either they need to both be negative or they need to both be positive. So if that's the case, the 2 and the 12 are not going to work. So I'm leaning towards the 4 and the 6 and making it x minus 4 times x minus 6. Remember, if you're not sure, if you were to double distribute this, right, you would get that -10x in the middle and you'd get a +24 at the end. That's how you know you're doing okay. All right, if I look at number 2, okay, to add to give me 6 but multiply to give me 10, I could use 1 and 10 or 2 and 5. Well, neither of those options are going to work, and it's not like there's another option I'm missing. You could be trying to think of, like, some of my students in the past will think of decimals. Don't make them decimals. That makes it harder on yourself. Factoring is supposed to be an easier process. So the fact that I tried all these different options, none of them are going to add to give me the 6x. We just write not factorable. So that would be a great example of, well, factoring isn't going to work for graphing this guy. So we'd probably either complete the square or make a table, and I'd probably complete the square if I had to. All right, let's look at number 3. There's a 2 in the front. So we can't just say what adds to give me -18 and multiplies to give me 16. That doesn't work anymore. What we did talk about was, well, if there's a number in the front and you can divide everything by that same number, that can make your life a little easier. And if you look, you can divide all of those by 2. If you do that, you get 2x squared minus 9x plus 8. And then I bet we can factor that guy. Let's see. If we use -8 and -1, that should work. Same thing with number 4. Notice the 3 in the front. So we can't just say what two numbers multiply to give me 45 and add to give me 6. It doesn't work. So, but if I can take the 3 out of everything, which in this case I can, that could help. So 45 divided by 3, yeah, it does give me a nice number. It gives me 15, so we're good. So let's factor this guy out here. What about, I'm thinking 3 and 5 somehow. But the 5 should be positive and the 3 negative. Again, if you don't 100% believe that that works, if you double distribute it, either off to the side or in your head, you can see how it gets you right back to that original question. All right, number 5, we briefly talked about this in a video, but like very, very quickly. Basically what I would do is notice how there's only 2 terms. I don't really like that. So a recommendation would be to write your quadratic like this. And say, okay, what 2 numbers add to give me 0 but multiply to give me -16? And then you can say, okay, well, what about -4 and +4? That would add to give me 0 but multiply to give me 16. Okay, there is a special name for this guy. Okay, we're going to talk about that here in just a second, because number 6, this is brand new, never seen one like this before. How am I supposed to do number 6? I can't divide everything by 4. That doesn't work. So it's like, well, how am I supposed to do that? This is also a special one, just like number 5 was. Okay, so down the bottom for number 7, when it says, what is the special process called for numbers 5 and 6? The name of it is difference of squares. So here's what I mean by that. If you have 2 perfect squares, then and they're being subtracted, you can factor them using this method. So let's look at number 5. I'll show you. X squared is a perfect square because x times x is x squared. So I would put x right here and x right here. 16 is a perfect square because it's 4 times 4. And because it's a difference of squares, because they're being subtracted, I make one of my factors a minus, my other factor a plus. So how that works for number 6, 4x squared is in fact a perfect square of 2x times 2x, right? 2x times 2x is the same thing as 4x squared. 9 is a perfect square because it's 3 times 3. And because it's a difference of these perfect squares, I'm going to make one of my factors a plus and one of my factors a minus. So that's one that we did not get a chance to talk about last week or on Monday. So I wanted to make sure I covered that for you guys, okay? Last question. It does ask what was different about the process for 3 and 4. So 3 and 4, what that's called is a GCF, right? If you can take a number out of the entire quadratic so you can factor what's left over, that is called a GCF. So actually, if you go back to the warm-up actually had like a 3x in the front, right? It's actually possible. What if, like, for number 3, what if I wrote it like this instead? 2x to the third minus 18x squared plus 16x. Then my GCF would no longer just be 2. It would be 2x. Oops, that should be a 9. Sorry, hang on. Let me undo that real quick. 2x squared minus 9x plus 8. And then when you factor it, notice how you get the 2x in the front. And that's also why there's 3 x-intercepts, or 3 solutions. So if you go back to this guy right here, that's what it reminds me of, this one right here. Okay, it's almost like there was a GCF of not just 3, but 3x. So those are 2 different, like, kind of special kinds of factoring, okay? So there's my answers again, just in case you needed it. All right, so that's it for today's lesson. The rest of the lesson is going to show up tomorrow. So as long as you followed along, you're good for today. But make sure if you have questions about anything we've talked about so far in Chapter 9, come see me during office hours so I can help, because I am going to throw a bit of a twist at you tomorrow. Okay, nice job, you guys. Let me know how I can help.